Hey guys, back again with another video with a new topic, that is asymmetric epoxidation, that is also known as Sharpless kinetic hydroxylation. See what happens in this epoxidation, there is the formation of two chiral centers and two functional groups at the same time. See what happens in this reaction, this transition metal catalyzed reaction. This epoxidation only works on the allylic alcohol. It completely works on allylic alcohol. Let's take one example for this. See what happens when we are taking allylic alcohol. What happens? I am writing one example here. Here we are having one allylic alcohol. This in presence of, I am writing it here, titanium tetrahydroxide, and in presence of an oxidizing agent, that I am taking the paracid. Not paracid, it is not paracid, we are saying per alcohol, oxidizing agent. This acts as an oxidizing agent, and we are taking here one chiral ligand. The chiral ligand I am using here, that is the DET, diethyl tartrate. But what is the difference? Why there is a difference between the formation of product when we are using DET? Sometimes formation of oxygen that delivers on the top phase, and sometimes it delivers on the bottom phase. What happens here? See, if I am using the rotatory, that means plus chiral ligand, then the oxygen will get delivered on bottom phase. That means the oxygen will be below the plane. Okay, what if I am using dextrorotatory DET? Dextrorotatory diethyl tartrate. Then the oxygen will get delivered on the top phase. That means the oxygen will be above the plane. So here we'll be having the product oxygen and oxygen. So this is the difference between the usage of chiral ligand as a dextrorotation and the rotation. So in this way I am explaining the enantioselectivity. We can say here that it is the enantioselectivity of epoxidation. See what happens. I am writing here allylic alcohol here. Here we are having see, if we are using dextrorotatory DET, okay, and if we are using rotatory DET, diethyl tartrate. Tartrate is a chiral ligand here. It is a very ideal chiral ligand here, and this rotatory tartrate is extracted from the grapes, and this is very expensive. It is very rare in case. Okay, so what will happen when dextrorotatory is there? The oxygen will deliver on top phase. Get it? And when rotatory is there, the oxygen will deliver on the bottom phase. Fine. This is about the enantioselectivity of epoxidation, asymmetric epoxidation. So let's take one example over here. See what happens. Any allylic alcohol I am taking, you just write anyone, whatever you want to like. So here I am writing any allylic alcohol when it is treated with the oxidizing agent. In presence of oxidizing agent, titanium tetrahydroxide, the formation of and second the chiral ligand is left. I am using here dextrorotatory DET. So when I am using dextrorotatory DET, what will form? OH will be here. The bond, the formation, the oxygen delivery will be on the above the plane. Okay, this is about the asymmetric epoxidation. Next we will talk about asymmetric dihydroxylation. Asymmetric dihydroxylation. In asymmetric dihydroxylation, osmium tetroxide is used. When we are using osmium tetroxide as a catalyst, what will happen? See, what will happen here? Here the formation of the double bond will be replaced by OH group, and here addition of OH will be syn. That means both OH group will attach to the syn position. So this is known as the syn dihydroxylation of alkene by osmium tetroxide. Here we are using one chiral ligand. I haven't mentioned the reaction conditions here. So here we are using the catalyst OSO4, and second thing, one oxidant, and I am using a chiral ligand. The chiral ligand we are using here as DHQ and DHQD. That means dihydroquinone and dihydroquinidine. This is the difference between the two. This is a dihydroquinone and this one is dihydroquinidine. In the same way, when we are using the dihydroquinone, we are using the dihydroquinidine, what will happen and what will be the product of the reaction? Let's see. And what happens if there is a steric hindrance? What will be the product formation? Suppose we are having I am attaching any group, RS here, RL, here RN I am writing, and here one is hydrogen. Okay, what happens when I am using the chiral ligand dihydroquinidine, and what happens when I am using the chiral ligand dihydroquinone? See, when I am using the dihydroquinidine, then the reaction, suppose we are using osmium tetroxide, there will be the syn addition of hydroxyl group. So what will happen? They will be above the plane. Or we can say the top face. When I am using the dihydroquinidine, they will be below the plane. Below the plane. That means I can say they will be on the bottom face. So this is about the asymmetric epoxidation and asymmetric dihydroxylation. Okay, thank you for watching the video. Don't forget to like and subscribe. Thank you.